If you watch the other videos, you know that Glade is used to set up a layout for a GTK application. Here is a layout. It consists of widgets. These widgets were dragged and dropped onto the screen from these control buttons up above. This actually is the layout that will appear when the program runs. But this is just a layout. It ends up as an XML file. Then you have to write a program that will read the XML file, that will process it, that will extract the pointers to all of these widgets, and will set up the signal handlers for all these widgets. For example, here the GTK toggle button has been set up to use a signal handler called onSample GTK toggle button toggled when somebody clicks it. Clicking it causes it to either depress or not depressed. It's a toggle button. A checkbox is similar. It's also a toggle, but it just looks different. Okay, so that's a Glade layout that produces an XML file. Then you got to write a program. Well, the program is pretty standard up to a point. Now, what actually happens when you click the toggle button is a different problem. What you mean by clicking the toggle button, I don't know. But getting up to the point where you handle the toggle button being toggled is pretty standard. There's a standard program. The signal handlers are standard. What you do inside the signal handler, well, that's of course your own application. But getting to the point where you can just drop down and fill in code in the signal handler takes a while. There's a lot of stuff you have to do, and it's tedious, and you make a lot of mistakes. Well, can you write a compiler to do that? Can you write a program that will read the Glade XML file and build the skeletal program? That's what we're doing here. And the answer is yes. And this is one of the examples I'm using. So this is the Glade program, the Glade layout. And you see it in the directory here. The project is called mumps. Now throughout this, the projects are called mumps, mumps.glade. With time, I'll improve it so you can change the project names. But for the moment, they have to start off with the word mumps, and the extension is Glade. Now, if I open up a terminal here, you can see mumps.glade. There it is. It's actually, I'm not going to change it because the Glade processor is actually on the screen at the same time. But you can see it's a pretty big, how big is it actually? It's 234 lines of easily read XML code. But it's, it's not all that difficult. But for example, here's a label. It's visible. Blah, blah, blah. Does it even have a name? No, it doesn't have... I don't see a name in there, so it's an unnamed label. There's where it belongs. These are, they're not uninterpretable, but they're not something you want to read a lot of. Okay, here's another label. It's a GTK label. Its ID is called label 2. That's the name over here. Where is label 2? Oh, there it is right there. And it's this label here. It says GTK switch. Okay, so it's label 2. They don't have to have names, but if you want them to appear in your program, they've got to have names. If you want to be able to manipulate them from your program. Several properties of it and where it's located, and those are pixels relative to the upper left-hand corner. Okay, so that's your XML file. You normally don't touch that. You could, but it's only when you're desperate to do something else. All right, the question is, can I build... okay, I'm going to get rid of this off the screen. This is the layout. I'll just drop it out of sight here and drop a couple other things out of the site. So what have I got? Well, I'm in this directory which has got examples. Do you see all those files that begin with the word on? Those are the signal handlers that it built. Let me just remove all of those, okay? And now you see we're down to just next to nothing. I'll do an ls-l. We actually have an executable here. That's the actual executable GTK, which if I run it will actually, you can see it looks like what the Glade file had in it. And it does work. I'm not going to play with it right now. Okay, that we will build. That's the thing that we intend to build. GTK-C is a template program. It's a setup. It's got the basics of what you need to get for the main program for GTK to run. These H files here, these header files, GTK 1, 2, and 3, contain information about the header files that will run the signal handling and so forth. They're part of the stack. They're built when the compiler runs. And there is actually the Glade XML file, and this thing with a squiggle is just a backup copy. You don't normally see it on the browsers, but it's there. User.h is included into GTK.c if you have any last-minute stuff you need to insert. Okay, so how does this work? Well, it's the make file, as you probably guessed. Let me go into the make file here. All right, the make file, get past the copyright stuff. This is all GPL. And I'm using the C compiler here. I've got versions for the C compiler, for the C++ compiler. I've got a version for my own mumps code, and I've got a version that is C++ but uses a mumps library. So anyway, C, that's what I'm in right now, the C version with the C examples. It uses good old-fashioned GCC. GTK is actually written in C. All right, so C is kind of your base level. And there is a remove command, and it removes all of the old files that begin with on. Each of these files that begins with on is going to be a signal handler. You'll see it in a moment when they recreate them. And then it runs the compiler. Compiler is two floors up. It's up above in this directory. And it's a mumps program. Sorry, it's mumps. You'll have to get the mumps interpreter and compiler in order to run it. I'll probably translate it into C or something, but I wrote it in mumps. And it's telling it wants the result to be a C language program. And you pass to it the XML file, this being the XML file. Then it writes a whole pile of stuff out. Then you actually compile it, and there's where we run the C compiler, optimized level 3. And they're I hate color diagnostics. They're hard to read. Anyway, you can turn that off or on if you want. There's a variety of things that are needed when you're running GTK or when I use GTK. So these are standard libraries that you'll have to have installed, and they may already be installed, or they may not. But anyway, you've got to get them. The installation for mumps, which is separate, will bring them in automatically if your system doesn't have them. And then there's a clean, which erases everything. Okay. Now let's look at what we had, which is just a bunch of stuff. Let's look at GTK.c. You can see here it's just a skeleton. It includes GTK1.h. It's a main program. It includes GTK2.h. Includes user.h. It's the main program. It runs into GTK main. That kicks off the GTK processor. And when the GTK processor returns, your program's over. So we say goodbye, and we end. And at the bottom here, we've got a bunch of, we've got an include of GTK 3.h, okay, which includes a bunch of includes, as you'll see in a moment. Okay, so that's the base GTK program. You could put other stuff up here, a lot of other stuff, later, if you want to. If you get global variables, they would go in here, right up here at the beginning, prior to the main and so forth, and then they would be global to all of the signal handlers and so forth. You generally have a lot of the global variables in a GTK application so that signal handlers can set values and other signal handlers can see them because they're not calling one another. It's going to be some way of communicating, either through global variables or some kind of a global pointer to a structure or something like that. Anyways, at the moment I'm not doing anything. That would be something you would do if you're actually writing. You're fleshing out the skeletal program. So make -b, that makes sure everything gets done. And there it's done. Now we do an ls -l, and wow, stuff appeared. What appeared? Well, first of all, the vi gtk1.h, what do we see there? Oh, there's a bunch of declarations. Look at all those declarations. They look tedious if you had to write them out yourself. Yes, they are. They're very tedious, and you got to get them right. You got to spell everything right. What are those declarations? I'm glad you asked. Well, they're these guys down the side here. These are all the variable names. Yeah, they almost come in the same order, don't they? They're going to come in the order which they see them in the XML file. And there's example switch, label 1, label 2. Yeah. So it's just done declarations for all of them. And it's gotten the correct data type too, because these are different data types, or they're similar data types, but they're different because they're different widgets. All right. And that's the security that you don't include it twice, and that's the standard GTK library includes. And some other stuff. Okay, well that's GTK1, and that's going to go at the beginning of your program. So at the very beginning of your program, it's going to be a bunch of global. Let me see, where is it? GTKC. GTK1 comes in here. It comes in before main, so those declarations are all global. They're outside of main. Okay, the next one coming down is GTK2. GTK2.h. What's that? Ooh, that looks like fun. That is the interface between your program and the XML file. Okay, it was done in the other videos, but initializes stuff. It contacts your mumps.glade. You see, it's written in here as mumps. I'll set it up later, so it could be any name, but at the moment it's mumps.glade. Put another name, it'll ignore you at the moment. But anyway, this is a work in progress. And we've got for each of those widgets, we access GTK builder get object, and we initialize the builder up here. Okay, builder is one of the things that was declared in GTK1. We initialize it with the contents. It parses the XML file, and then when we get down to something like toggle button, we invoke a function, it's a built-in function, GTK builder get object. And what it does, you pass down builder, which is the parsed version of the XML file, and you say, I'm looking for sample GTK toggle button. You give it its name in quotes, and it says, oh, yes, we found it, and it returns you a pointer. Now, the pointer name doesn't have to be the same name, but boy, it's a lot easier if they are. Just keep them the same. You have to here. It's going to keep them the same. But, so the name used in the Glade file, the ID, you see that comes under the ID toggle button. There it is there. It's under ID here, sample GTK toggle button. That's the one that's the name that's being used here. So it gets all of them. And then down here it connects all the signals someplace connects all the signals. It's got to destroy. When you click the little X in the upper right hand corner to kill the box, there's the destroy signal. You could actually elaborate on that to do something funny when you destroy things, to close files or something like that. But at the moment it's just it just calls GTK main quit, which ends the program. Connects the signals. All of these, not all these widgets, but many of them have signals. Okay? In other words, if somebody does something, generally speaking, it's a click or a drag on one of these widgets, it sends a signal. Well, this sets up this connection between the signals and the code that processes the signals. Okay, and then we show the window. Okay, which is always nice to see it. All right, so and if we go back to GTK C again, okay, there's GTK2. That's where it does the coding that actually connects you from the XML to the program and sets things up and shows it. This thing here is anything you want it to be. At the moment, it's nothing. It's just an empty file. GTK main, that kicks off GTK. When it returns, the program's over. GTK main loop sits there waiting for signals and processes the signals. Then down at the bottom, which is outside the main program, there's GTK3.h. Okay. GTK3.h, it's a bunch of includes. What is it including? It's including all these header files that got built. What are in the header files? The header files contain the signal handlers. They're all individual ones, doesn't matter how many you've got. They're very tiny, but those are the signal handlers. Okay, what does a signal handler look like? Let's see. We've been using on toggle button. It's at the bottom. SAM sample GT. I used to use shorter names. Toggle button .h. Make this a little bigger. So Okay, I'm going to look at that particular signal handler, which was built by the compiler. What's in it? Very little, but it is a signal handler. All right. What it'll do is say, "Hey, you called me." It writes out its name, and then it will write out the status of the button. In a signal handler for a toggle event, you probably want to know if it's toggled or not toggled. All right, and then based on that, you'll decide to do something. This is a Boolean, true, false, that comes back, 0 or 1. So the function in GTK is GTK toggle button get active, and then you pass down the pointer to the toggle button, and it comes back and says 0 or 1, and you can see I'm printing it out as an integer, and that it'll tell you if it's toggled. Now you'll notice it came in as a widget. Okay, but I'm casting it to be a toggle button because the widget's generic. Everybody's a widget. But I'm casting it to be a toggle button because that's what the function expects to receive. Yeah, I could have I've written the code so it would have said toggle button here at W, in which case I wouldn't have needed the cast. It's 6 to 1, a half dozen the other. This actually takes place at compile time. There's no processing at runtime as far as I know. All right, so what would you do? This is the skeletal program. So whatever you wanted to do when it got toggled, you'd put the code here, and you'd probably first of all have an if statement. If GTK toggle button get active, blah, 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 equals 1, do this. If it's equals 0, do that. And whatever it is you meant to be done by a toggle button, you would put in here as code. And that's what we've got here. Let's look at one of the other ones. Switch. On what is it? On example switch. Okay, again, they're all fairly simple. These are the skeletal. You go in there and fill this out. Again, it's switch is like a toggle button as well. It's either on or off. Okay, it says, "Hey, I'm the switch." Tells you what program got called. You can delete that, of course. And then again, it's a number that comes back. It's an integer, and it runs the program the function GTK switch get active. I don't know why it's not toggle, but anyway, it does the same thing, and you cast it as a switch, and you get back 0 or 1. It either is active or it's inactive, on or off. All right, and there's bunches of things like this. So essentially, once you've built the Glade application like that, and you've set up the signals over here, you can compile it by writing make space dash capital B, and it will create the skeletal program. The only thing you got to be aware of, again, in the make file here, and this is an issue I don't know what to do with. In the make file here, it deletes all the old all of the old signal handlers. You may want to comment this out. The compiler itself, if it sees there's a signal handler already in the directory, it won't overwrite it. If there's no signal handler, it will create one. Since these are all examples, I've got this RM in here, this remove, that deletes everything, so they get recreated entirely each time. So if you're actually doing development, you want to make sure you want that line in there. You can comment it out by going to the beginning of the line and putting in a pound sign. But anyway, just keep that in mind. All right. In terms of the signals up here, this one, toggle button, what you do to add a signal is you go and you click. I don't have one up here. Let me just pull something down. Let's pull another button in here. Okay, there's a button. It's going to be a meaningless button, and it's too far over, and I'm going to make it smaller so it's not a big chunky button. Oh, what am I doing? I'm on GTK fix. What happened to the button? All right, there we go. All right, and move it a little further over. All right, it's a button. Okay, it doesn't have an ID. You got to give it an ID. I'm going to type XXX. It's a legal ID. It's also simpler for me to deal with, so I don't have to type a lot. Okay, packing is where it goes. Common, generally you don't touch anything except down here, the height and width request. They default to 100 by 80 on almost everything, and it's usually too big. If you uncheck it, it'll default to the size necessary to hold the content, the text or icon, whatever happens to be in there. So that's as big as it needs to be for button. The word button actually appears down here. If I type my button, you see it changed the text and it got a little bigger. Anyway, so it's a button. And most of this is pretty standard. You generally don't change all of that stuff. And you go over to signals. Well, buttons basically have one thing that you do to them. You click them. And this is where you set up the signal handler. There's a few other things out here. I'll drag that. I want to drag it too far because you don't use them. You could, but you don't. Clicked. That's the important thing for a button. If you click on it, it sets up. This is where you're going to type in the name of the signal handler. All you have to do is start typing ON, because they all normally start with ON. And it suggests the name should be on XXX clicked, which is a good one. Okay? And there you see it's clicked. You're not done. Until you hit enter, it didn't take it. People do this all the time. They say, oh, well, I've done it. No, you haven't. You have to hit enter. Now you see, now you've done it. So now there's a button on there, and it's got a signal handler. So I'll save this out here, and I'll go over here. And just for the sake of argument, you see there's no on XXX. All right. And now I do an ls again, ls-l, and you see down at the bottom there, on XXX clicked has suddenly appeared. And you see it just tells you it's been clicked. I mean, there's no active or inactive status for a simple button. It's either clicked. It's been clicked. What do you want to do? And this is where you'd put the code, the what do you want to do code. Okay, so let's get rid of that button because it's actually, I don't need it, and the button's gone. And you of course want to delete it back here, but anyway, since it's deleting everything each time, not really a problem. And I'll save that, and get out of here. And we'll go to the top and we'll look at a bunch of different examples. What does this thing actually do? Now it's in my mumps distro, and this is the top of the mumps distro over here on the right hand side. It has two directories. One is the language processors, the other is projects I'm working on. In the language processors, the second one, the legacy is a real old version of mumps, 20 some odd years old or more. This version down here is the one you need to be in. What do you need to do in order to run it? You need to open a terminal. You need to become root. I'm going to stretch this out. You can use su, excuse me. You can use sudo, but you need to become root. Okay, my password. Now I'm in here. You need to run two programs. The first one you need to do is configure native mumps script. Don't run the makefile. These guys will run the makefile. Let them do it. Configure native mumps script. What that does is going to go out and get any from the repositories, get libraries and so forth that you're going to need. So it's /configure native mumps script. Now it's not going to do much here. It's just going to roll through them because I already got the libraries. It's just doing apt gets to your repositories. And again, this is only compatible with systems that are apt-get or apt compatible. I have got nothing for yum or any of the other things here. So it's basically that. So it did it. It'll take longer if you are lacking the packages. It'll actually download the packages and install. Like there's the GTK packages, and here's the WebKit. There's actually a WebKit in it. So anyway, it'll take longer if you have nothing. Yeah, if you've like me, you already got them. It'll run quick. Now it's /compile, and the compile one. Let me go over here. Is native single user mumps. Native single user mumps.script. This is where it runs the make file. It's running configure first, then it run the make. But it's compiling all the different parts of it, and chunk. And it takes a moment here. Now it's actually building the libraries. It's installing the libraries into /user/bin. All right, they're there. Now get out of this. You can see over here a lot of these guys have lock on them because that now that it was actually root that created them. You can change those back to your ownership. You have to be root to do that. But anyway, all right. And so you just type mumps, and you can see there's the mumps interpreter. Type it correctly. Write 1 + 1. And we get the answer 2. It's an old language. It's still used a lot in medicine. All right, so that's how you install it. And I'll go back up here. Now under projects, you got a bunch of different ones, but you're looking at the Glade compiler. Go down there. There is the actual Glade compiler there. The code is a mess. Yeah, I'm working on it. Please, I'm glad most people don't know mumps because they'd say, ooh, this is a mess. Well, it is. I call it GTK compiler there. It's 364 lines of, those are the widgets it recognizes. If your widget isn't one of those yet, it's not yet recognized. And that's where it sets up the casting and so forth for initialization. But anyway, whatever this means, that's it. That's the thing that we're using when we run. So, all right, we've got the C examples, we've got the C++ examples. MDH examples, those are written in C++, but they include libraries that let you access the mumps database. And then there's plain old mumps examples down here. So we're going back to the C examples. We saw the button widgets. Let's go back down there and get this off the screen and start up another terminal. Come on. We've already compiled it. So there it is. Now, when I run this, you will see stuff happening. Because every one of those, like simple button, there's the button clicked, toggle button, active, inactive, okay? GTK text button, or excuse me, check box, checked, unchecked. Radio buttons, you get 2 signals for a radio button. One guy got unchecked, the other one got checked. So you see radio 1 is inactive, whereas it was active. Radio 2 is now active. With a radio button, you get 2 signals. One to indicate who's been deactivated and another one to indicate who has been activated. The GTK switch, which shows you on and off. Again, you will have to write the code to give meaning to what on and off is, but it's built the skeleton for you. All right, combo box, it's a drop down. Veggies, three vegetables. You get 2 signals. One is you get the combo box. The combo box contains an entry box. So I'm giving you 2 signals here. One is for the combo box change. The other is for the entry box change. The entry box actually contains the value. CB entry, it comes up as peas, so it knew what you do. If I select carrots, you can see carrots were selected. And it also has set up a signal for the combo box itself having been changed. The one you only need, you really only need the one where the entry box has gotten changed. All right, what are these other guys? Color selector. So you select color and you say, okay. It'll tell you the colors you selected, RGB from 0 to 1. So I selected one which is mostly red and green, which looks yellow, very little blue. And the alpha is the transparency, RGBA. All right, and in terms of a font chooser, pick a font. Let's pick that one. It's Greek, I guess. It comes out as a standard symbols. Bold italic is what its name is. Suruma Medium. There it is, Suruma Medium, and the font size is 12. So those are buttonish objects. Okay, and let's go up one here. We'll go down into input objects. These have already been compiled. I think they're all functional without me recompiling. GTK entry, if you start typing, it gets a signal for every letter you type. Okay, you would probably have a button next to it to say find or do whatever it is you want to have done. This is very similar to search, except there's a delay, a fraction of a second delay between when you type it and when you see it, when the signal gets sent. It allows for that was empty, of course. It emptied it for fast typists. Anyway, it's slightly different, and Control G sends a next signal. And this guy's file chooser. So if I just choose a file here, it'll come back and give me the file that was chosen. and it'll give me the full freaking name, which is the entire world there. Okay, that's not too many there. All right, kill that. We'll go back up here one more. Slider widgets. Open in terminal. GTK is ready to go. Yeah. Okay, slider widgets, sliderish widgets. The spin button. Every time I click it, you see you get a different number going up and down. This is a scroll bar, and you back and forth. You can see the numbers going up and down. This is a GTK scale, which is very similar to a scroll bar visually and performance-wise. And I don't know if this is, I decided to put the calendar in here, so you see it's year 20, month 6. It starts months with 0. So July is not the 7th, it's the 6th month. I didn't write it, that's how they do it. And it's the day is the 20th. If I go forward a year, you see the date stays the same, but yeah, it's a calendar, all built in. You might want to, in terms of the sliders here, they require adjustments. See the adjustment here? So that's the spin button. It's got an adjustment. The scroll bar, it's got an adjustment. All right, that's where you set up the limits, by the way. And the scale, it's got an adjustment too. So those adjustments are, you see the 3 of them up here at the top. All right. There's only one left, which is a template, which is basically a big old empty file. Oh, well, I guess it's not empty. I guess I was fiddling with it for when I previous version of this thing, but it's supposed to be the template. I'll clean it out in the distro. But yeah, okay, I'm still working on it. In the mumps version, there are some tree things that are not yet functional for the C and C++ because I don't have access to the mumps database in these guys. But it takes a moment because it's actually loading part of the tree there. And if I say load a table, it loads. These are called the mesh subheadings. They're from the 2003 edition. They're out of date now, but it doesn't matter. They're still examples. The medical subject headings from the National Library of Medicine. Okay, if I clear the tree store, and here's when it actually loads it as a tree instead of a table. It takes a while because it's pretty big. And as you see, if I click down here, I can click through these things. As I hierarchically telescope, well, that one went over the edge. Then I should be a little wider in order to handle that. But yeah, that's and there's some other examples up here. This one had a bunch of examples. This is not in the C examples yet, but other things will be soon. So hopefully this is useful. So basically the idea is if you can draw it in Glade, if you can get down there in Glade and let me just bring up the slider widgets again in Glade, and you can lay it out, and you set up the signals. For example, here the calendar has signals here on calendar day selected. And that will any change in month or year will generate a day selected signal. But you set up the signals. You name the signals the same as the ID, example calendar in this case. I guess it has a starting item. Oh, that's what I've actually checked over here. If I check it over here, no, I guess not. I don't know where those are coming from. Those are not today's date anyway, but they were the ones that were clicked. If I double click it, there's I don't know why where those come from. I never set those up before. It's got some settings in it. But yeah, anyway, you've got to give it an ID. Make sure you give it an ID and not a widget name. Widget name, no. ID, yes. Okay, signals should have the ID name in them. And if there's other signals any one of these signals you put down, it'll generate a signal handler for you. So what has this done? It has taken the process of converting that XML file into a skeletal program, done it quickly. And then you would go into the individual handlers, such as, the spin value up in there, and you'd fix them. You'd do what you wanted to. So spin, and there's the function that gets you the important thing of the spin button is what's its value. Okay, there's another function which is set, where you could set a value, but more likely you want to read the value. That's the prominent function for a spin button. And what would you do? You would write additional code here. That doesn't look like very good code. But you'd write code to do something when the spin button changes. And you can do all sorts of stuff. All right, that's my, let's close without saving. That's my offering for a sort of GTK compiler.